Welcome to the Brainiac. Before we go into today's video, let us look at a recap on how far we have gone in vectors. So previously on the Brainiac, we saw how to graphically represent a vector. That is done by drawing arrows. Not just arrows, these arrows represent the magnitude of the vector, and there were some rules in drawing these arrows too. The first rule was, when drawing the magnitude of any quantity, the line should be drawn equal to the amount of magnitude applied. For example, if a force of 70 newtons is applied, then a larger line should be drawn. But if a force of 7 newtons is applied, a shorter line should be applied. And we also studied that the direction of the arrow is the direction of the quantity applied. And we also studied that we denote only vector quantities with an arrow. And we also studied that when denoting vector quantities such as force, velocity, and momentum, we should represent the direction of their motion. It can be right to left, or left to right, or either both sides. I think that's enough for a recap, and let's go inside today's video. In today's video, we are going to talk about the vectors notation. We already know that the length of an arrow is the magnitude of the quantity, and the arrow's direction is the quantity's direction. Consider the following figure. For example, consider the vector applied in this box, known as x is force. So the force applied here is 7 newtons. Thus, force is a vector with a 7 newton magnitude, and if you point its direction, it's in the right side. If you put it up on a coordinate plane with both the x and y axis, we can say the force 7 newton acts in the positive x direction. The force here has a magnitude of 7 newton, and also it is in the positive x direction. Hence, we can write it as, carefully look at this point. This is important. If you want to try this out, you can even pause the video for a moment and write another way of representing the force. And if your guesses were correct, we denote the force also as we equalize force to its magnitude times x with the mark of explanation on top of it. The x with the explanation mark on top of it represents that the force is in the positive x direction. Consider a ball is thrown upwards and it gains a velocity of 4 meters per second. And all of us know velocity is a vector quantity. Forgive me if my handwriting is terrible. We clearly see the vector represents the magnitude 4 meters per second of velocity, and its direction is towards the positive y direction of a Cartesian plane. So, we can denote this particular example also as we did before. We equalize the vector v, its velocity, to its magnitude 4 meters per second times y with the explanation mark to indicate that it travels in the positive y direction. So you might wonder one thing, why are we having two explanation marks on top of x and y? Well, let's look into that too. Well, When representing x and y with an exclamation mark on top of them, they are known as a unit vector. A unit vector is a vector with the length of 1 unit. So when I multiply the unit vector by the magnitude, it does not change the magnitude of the magnitude, or in simple terms, it does not change the magnitude's value. Let us take an example for understanding. Let us take velocity. We have a velocity of 2 meters per second acting on the positive x direction. So if you see this positive x is a unit vector, and the value of a unit vector is 1 unit. It simply means 1. And if you multiply 2 meters per second into 1, you get the same value. So as I mentioned before, the magnitude of the magnitude does not change, or in simple terms, the magnitude's value does not change. It does also point in the direction. So the x with an exclamation mark means a vector that points in the direction of the x-axis, and it's only 1 unit long. And in simple ways, y with an exclamation mark means a vector that points in the direction of the y-axis, and it's only 1 unit long. So simply, if I multiply a magnitude with 1 unit or a unit vector, I will have a physical representation or mathematical representation of what that quantity is. So simply it means, I'll take this example. So simply it means 2 meters per second pointing in the x direction. But for people who study mathematics, this can come in different ways. There are different ways of representing x, y, and z. Whoa. What is this z and where did this come from? Z is a representation of the third dimension. We'll talk about that later in another video. So, as I said before, in mathematics, the representation of x, y, and z is totally different. So, x would be represented by an I with an exclamation mark, and y would be represented by a J with an exclamation mark, and z would be represented by a K with an exclamation mark. So that's it for today. Our next video on physics would be the components of a vector. On that video, we will see about vectors acting on directions like this and this, but not with a curve here. That's an error of mine. We'll talk about them in another video. Thank you for watching and stay subscribed to Brainiac.